Project is fine before you go here. Okay. Now we continue the exercise for the Fourier sine series. Okay, try to sketch the odd extension first. Okay, odd extension. Okay. So from 0 up to 1, 0 up to 1, we have t. Okay, the t is here. Now find the other half. Find for the other half. So we reflect this one through the y-axis, and we reflect this through the x-axis. Okay, we get a straight line. Okay, we get a straight line, and we ignore the dotted line. Then we copy paste. Copy paste. This is the odd extension. So we copy the section in this interval and paste it here. And also in this interval. Normally in the questions, it will mention sketch the graph from, for example, this one, -3 up to 3. You will be given an interval. Okay. Then if -3 up to 3, that means you need to copy this one, paste it here and here. Okay. Normally the interval will be given. Okay, what is the L for this question? What's the L? L is 1. Okay, 1. Is now we are finding for the Fourier sine series, meaning that we just need to find for Vn with this formula. So we have you substitute the L, and you have only one function of t, so we do not separate the integration. Okay, when L is 1, that means your angle will be n pi t. N pi t dt. If you look at the past year questions, actually, the questions under this chapter, Fourier series, is quite easy to be solved because the questions more or less is the same. If you look at the past year question, so I hope all of you managed to score for this Fourier series. Okay, because first you need to identify the given function, is it defined in full or defined in half? If it is defined in full, meaning that you use the full range formula, full range formula. But if you are given the function is odd, still you can use the full range formula. But just that if it is even, Bn is 0. If it is odd, A naught and An is 0. Okay. If the function is given is half, that means you need to do the either odd or even extension. Then use the correct formula. If even, we use Fourier cosine. If odd, we use Fourier sine. That's it. The integration is either direct integration or tabular method. You won't go far from this. Okay. So I would say Fourier series is a topic that you must score. Okay. So if you look at this one, polynomial with sine, tabular. Tabular. Integrate sine, we get negative cos over and pi. Okay, integrate once again, negative sine and pi t over m squared pi squared. Okay, so even though maybe you commit some mistakes, careless mistakes during the integration or here, tabular method, okay, still you will still get the marks for manage to come up with this line. Okay, you have the working, you have the marks, you have the working, you have the marks, and then you come up with correct answer from this one, you get the marks for the working. Okay, and also when you substitute the t value into the t, you will still get the marks for the as a working. Okay, so if you commit mistakes right from the start, still you can score maybe 50% from the total marks of that question, because it carries the marks for the working and solution. Okay. Here, your Bn is 2. Do not forget about this 2. You still have a 2 outside. So 2 negative t over n pi cos n pi t plus 1 over n squared pi squared sine n pi t. 0 up to 1. Okay, so when we substitute 1 into t. So we have cos and pi. Okay, when this one substituted into this t, sine and pi is 0. Okay, remember this one, sine and pi is 0, cos and pi is negative 1 to the power n. Then 0 into this t. That means 0. 0 into this t, sine 0 is 0. So this is the formula for the Fourier sine series. We just need the Vn. So you just put the Vn that you found into this. Here, also you get the marks for the working and solution. Even though you put the wrong one. Okay, let's say you have some characteristics in the middle, then you get the wrong one. Okay, still you get a mark. Okay. Any questions? Now we look at question number 2. Okay, question number 2. Question number 2. Sketch the odd extension. Okay, so this one we have draw this on Monday. Okay, t 0 up to 1. Okay, let's say 1 is here. This is t, and this is a straight line. Okay, this is a straight line because power of 1. So when this is a straight line, okay, we can use the endpoint to find 2 points. Then we join the 2 points with one straight line. So you treat this one as x, okay? This one you treat as x, this one you treat as y, x and y. So when x is 1, your y is 1, right? When x is 1, your y is 2 minus 1, which is 1. So 1, 1 is here. When x is 2, your y is 0. So 2, 0, 2, 0 is here. Okay. Then find for the other half. Okay, this is odd extension. So for the odd extension, if you reflect this one through the y-axis, suppose you get this, then reflect this through the x. So this is odd extension. Odd extension. Okay, then copy paste. Copy the segment in this interval and you paste it here. Now what is your L? L is 2. Okay, L is 2. To be fine for the Vn. Okay, substitute the L by 1. Seven sign for attendance. Okay. So this interval from 0 up to 2. 0 up to 2, your FT are different from 0 up to 2. So you have to break this integration into 2. One from 0 to 1, another one from 1 to 2. Okay, because you have two different FT functions. For both of these two integral, you have to solve using tabular method. Next time we get a negative cos over n pi over 2. Bring the 2 up. Okay, n pi over 2, but you bring 2 up. Okay, because n pi over 2 is your denominator. Okay, your denominator is n pi over 2. The 1 over 2, you can bring it down. Okay, bring up the 4. minus plus t times this one. 2 over n times t. Now substitution of values. T. 1 into this t and also this t. Negative 2 over n pi plus n pi over 2. Okay, then when t is 1, sine n pi over 2 is not 0. Pi over 2. Okay, minus 0 into this t. Okay, 0 into this t, 0. Plus 0 into this t, sine 0 is 0. Okay, then plus 2. 2 into this 2, 2 minus 2, you get 0. Okay, 2 into this t, cancel out the 2, you have sine and pi. Sine and pi is 0. Then 1. 1 into this t, 2 minus 1 is 1. 1 times negative 2. You have negative 2 over n pi cos n pi over 2. Then 1 into this t, sine n pi over 2. Pi squared sine n pi over 2. Okay. These two are the same function. 1 minus 1 plus. And these two are the same function. This is plus. This is also plus. So 4 plus 4, 8. Okay, this is your Vn. Okay, in the slides, okay, the final answer, 8 over pi square is factorized. It's being put outside the summation because 8 over pi square is constant. Okay, so we can factorize the constant. And those with n, the function must stay inside the summation because summation is for n from 1 up to infinity. Okay, any questions? Okay, next we will look at the last chapter, chapter 5. Basically, chapter 5 is divided into 2 parts. Okay. One is we will solve the PDE, the partial differential equations, analytically. Okay, analytically. And the second part is we will solve the PDE numerically. So the one we solve PDE using analytic method. Okay, that is called method of separation of variables. It will be coming out, it will be covered under your assignment. Okay, and the one we solve PDE using finite difference method, that means the numerical methods, will be covered under your finite exam. Okay. So, okay, maybe you can join the online class because I want to show the examples in the slides. Because the projector is, I don't know what's happened to the projector, but before you guys come in, it's just perfect well. No issue at all, but now maybe some of you have the magnetic effect. Okay. Okay, so you just join the online class. Okay, you join the online class. You look at the screen. If this is not the screen is not too clear to you. Okay, now we start the introduction to the PDE. Okay. In chapter one, you have learned what is the difference between the ODE and PDE. Okay, so this PDE is the one where it has more than one independent variable. Okay, it has more than one independent variable, and we will use the del instead of d. The dy dx is ODE. The del z del x or del z del y, that is PDE. Okay, partial differential equation. And this one, we look at the partial derivatives first. There are two different notations that we can use for partial derivatives. Okay, either we write the del z del x, or we write the z subscript x. Okay, z subscript x. Okay, what is z and xy? Z is the dependent variable. Okay, z is the dependent variable, and xy are independent variables. Okay, so when we differentiate z with respect to x, we write this z subscript x, or we write this del z del x. Okay, we do not use p. Okay, we use del. Okay, why we use del? Because we have to differentiate between what is the independent variable that you are differentiating with respect to. Okay, because you have x and y. Okay, you have x and y. When we are differentiating z, you are differentiating z with respect to x or y. Okay. So this one, either you can write it this way or this way. Okay, and for second partial derivatives, okay, this is the second order, z x x, meaning z, we are differentiating z with respect to x twice. Okay, or we can also write in this form, okay, del square z del x squared. Okay, they are the same, they are referring to the same thing. Okay, and another one, second order mix. Okay, mix partial derivatives, meaning that we have x and y. Okay, we are differentiating z with respect to y, then x. Okay, these two are referring to the same thing. If you use this, okay, if we use this, meaning that we are differentiating z with respect to y first. Then from the output, we are differentiating with respect to x. Okay, but if you use this notation, this means we are differentiating z with respect to y first, then followed by x. So if we use this notation, we will read from the back to the from the right to the left. Okay, y first, then x. If you use this notation, then from the left to the right, y first, then x. That's why these two are referring to the same partial derivatives. Okay, this is another one. Okay, x followed by y. Okay, x followed by y. So any equations that containing at least one partial derivatives is called as a PDE, partial differential equation. Okay, so in this PDE chapter, we will look at mainly two applications. Okay, there are three here. Here listed out three, but we will just focus on these two, the first two, heat equation and wave equation. Okay, this is the heat equation that governs the heat flow. We will examine how is the heat being transferred by conduction in a rod. Okay, and the solution. Okay, you see U is the dependent variable x and t are independent. So that means our solution will be u in xt. Okay, u is the solution. And this solution, it represents the temperature of the rod. The temperature of the rod at time t at point x. Okay. And the other one, this is a wave equation. Okay, this wave equation, it governs the motion of a vibrating string with fixed end. Okay, that means we fix a string at two endpoints and we just stir the string. Okay, then the string will vibrate. Okay, the string will vibrate. And the motion is governed by this wave equation. Okay, so the solution is also u. Okay, but this solution, it represents the small displacement. Okay, displacement of point x at time t. Okay, actually this displacement referring to the displacement from the x-axis to the point of this. That's been the vertical displacement. Okay, this one I will explain more when we are in the wave equation topic. Okay, so if you look at the difference between these two, heat equation and wave equation, the heat equation, this one is in first order, this is in second. But for wave equation, both are in second order. Okay, and there is the third one, Laplace equation. Okay, this describes the steady state temperature. Okay, temperature distribution in a thin flat plate. Okay, thin flat plate. Okay, but we will just look at these two. Okay, order of a PDE is the same with the ODE. When we want to identify what is the order of differential equation PDE, we will look at the order of the highest partial derivatives. Okay, so for example, this one, this is the first order partial derivatives. This is the second order partial derivative. So the order of this PDE is second order. Okay, the highest one. Okay, this one, this is third order. Third order, this is ZY is first order. That means the answer for this PDE is third order. Okay, same exactly as the ODE. Okay, this is another example. Okay, this one, what is the order for del W, del R to the power of 4? First order. Okay, this is first order. This is third order. Okay, first and third means third order. Okay, the highest one, third order. And this one, second order, first order, that means second order. Okay, very straightforward, this one. Okay, now we just go through this exercise. What is the order for question number 1? First. Okay, both are first. Number 2? Second. ZXX and ZYY are both in second order. Number 3? Second, because of UXY. Okay, UY is first, UX is also first. This is also first, so this is second order. Number 4? Second. Okay, UXX, UYY. This is first order. Okay, number 5? Third order. Okay, third order because of this third order YXX. Okay, this is also third order. Number 6? Third order ZYYY. Third order, the highest one. And number 7? Second order. Okay, this is second, this is first, this is also first. So the highest one is the second order. That's why the order for this PDE is second order. Okay, very straightforward. Next one, we look at the linearity. Okay, linearity of a PDE. So there are two requirements. Okay, two requirements. The first one is the degree of the dependent variable u. Okay, remember your u is the dependent variable now. Okay, the u must be in degree of 1. Okay, that means power of 1. And also its partial derivatives, the degree must be also 1. Okay, that means whenever you see the u, okay, it must be power of 1. And the second criteria is, okay, we call all the u, ux, uy, uxy, uxx, or uyy, all this as u terms. Okay, u terms. So the coefficient of the u terms must be independent of u. Independent of u means free from u. That means it cannot be u. It must be free from u. Okay, the coefficient of the u terms it must not be U, cannot be U, in other words. Okay. So if the PDE satisfies these two requirements, that means it is linear PDE. Okay, now we look at the first example, this one. Okay, we check for the first criteria, the power of 1. Okay, there's a U here, this is power of 1. And there's another U here, this is square. So meaning that, based on this, we can conclude that this is a non-linear PDE because of the square here. Or all U terms must appear at degree of 1. Okay, and if you check for the second criteria, when you see U, you look at the coefficient function 2t. This is not U acceptable. Okay, there's a U term here. The coefficient is 3, -3. Okay, which is not U. So this is also acceptable. So the only factor that leads this to be non-linear is UX squared, the square. You get what I mean? Okay, if you look at the second example, okay, now we check for the first criteria. Okay, UX, this is UX power of 1. This is U power of 1. This is U power of half. So this violates criteria. So this is a non-linear PDE because of the U power of half. Okay, if you look at the second criteria, we check for the second criteria. This is UX, but the coefficient is U again. So this is not acceptable. Okay, this leads to the non-linearity. Okay, this leads to the non-linearity. Okay, and this U terms, the coefficient is +1, no issue. But because of U power of half, okay, it leads to the non-linearity of the PDE. So the answer is non-linear PDE because of the U power of half, and also this UX is multiplied with U. Okay, two factors that makes it non-linear. Okay, any questions for this one? No. Okay, now we go through this one. Is this linear? No, because of square. Because of the square on the U term. Okay. Second criteria is being satisfied. Okay, because the U term here is X, not the U. Okay, no problem. The U coefficient is +1, no issue. If you just get the square, it makes it a non-linear PDE. Okay, number 2. Linear. Okay, linear because U all in power of 1, and their coefficients are all constants, +1. Okay, number 3. Non-linear because of. Okay, number 3, equate of square. Number 3. Linear or non-linear? Non-linear because of the coefficient of UT. The coefficient of UT is again U, which is not acceptable. Okay, this one no issue, this is X, not U. Okay, and all this U power of 1. Okay, so the only factor that leads it non-linear PDE is this coefficient U. Okay, number 4. Linear or non-linear? Linear. If you look at all U, there are appear at power of 1. Okay, all power of 1. And their coefficients not U. So it is linear. Okay, number 5. Non-linear because of the square. Yes, the square. So this one power of 1, no issues. Their coefficient functions also no issues. Okay, so the only factor is the square here. Okay, number 6. Number 6 is linear. Okay, U all power of 1, and their coefficients of their coefficient functions are not U. Okay, their coefficients are not U. Okay, so it is linear. And the last one. Linear or non-linear? linear. We just look at u. Remember this, we just look at u. The u must be power of 1. This is also power of 1. And the coefficients of u term, this is 1. This is x. There are not u. So linear. Okay, we don't look at the t squared because this is not u. It is e. It doesn't matter what is the power of the independent variable. We just look at the u terms. Okay. Any more questions for the linearity? Okay, next one, homogeneity. Homogeneity means that either homo or non-homo. So the criteria is if all of the terms of the PDE depends on the dependent variable, then it is homo. Okay, so in other words, if it is homo, it means all of the terms you will see the u term. You will see the u terms in all of the terms. Okay, for example, this. How many terms do you see here? How many terms? You have 4 terms. 1, 2, 3, 4. There are 4 terms altogether. But this term, it has no u. This is free from u. Okay, there's a u here, there's a u here, and there's a u here. But for this term, it has no u. So this is non-homo. For homo, you will see u for every single terms in the PDE. Okay. The explanation. One is not depending on the dependent variable. Okay. This one depends on this one depends on you. This one depends on you. This one also depends on you. But this does not depend on you. Okay, now example number 1. Homo or non-homo? Non-homo because of 3x is free from u. Okay, number 2, homo because you see the u in every single terms. Okay, now we look at this exercise. Okay, number 1, homo, non-homo. Huh? Homo, u. Number 2, homo. Number 3, non-homo. This is free from u. Number 4, homo. Number 5, non-homo because of this 2y. Okay, number 6, homo. Number 7, homo. Okay. Okay, next one, classification of PDE. Okay, this is a second order. See, second order, linear. That means all these u there are appear at power of 1, and their coefficient functions are not u. Okay, this is a second order linear PDE. So if you have a second order linear PDE, we can classify. Okay, we can classify the equation either it is hyperbolic or parabolic or elliptic. This is not even as the appendix. You have to remember this one. You have to state this in your mind. Okay. Now this A, B, C, D, E, F, they are all constants. Okay, all constants. So we will compute for the B squared minus 4AC. If it is positive, it will be hyperbolic PDE. If it is equals to 0, it will be parabolic. If less than 0, it is elliptic PDE. So 3 different categories. So what is the ABC? If you look at this one, A from UXX, B from UXY, C from UYY. The D, E, F, we just ignore. We just obtain the ABC from second order partial derivatives. Look carefully. Second order partial derivative. The first order and u, we just ignore them. Okay. And what is the B? B is taken from the coefficient of the mix xy. See, this is the same xx. This is yy. The one makes the value of B you take from the coefficient of the mixed partial derivatives. And your A and C can be AC or A, C here. It doesn't matter. As long as they are the same, repeating X, X or Y, Y, no matter which one is A, no, which one is C, it doesn't matter. Okay, because A times C is the same as C times A. Okay, no difference. So first, identify the B and find for the A and C. Okay, if you look at this example, okay, what is your A? Sorry, what is your B? We find for the B first. What is the B? -1. Okay, from the mix. Okay, the one from the mix. B is -1. And we find for another the second order, UX, UY. So A is 3, C is also 3. So when you compute for the B squared minus 4AC, you get negative value. So it is elliptic. Okay. Now if we look at question number 2, what is your B? 3, because from the mix XT, okay, B is 3. Then we have only UTT. We do not have UXX. Okay, we do not have UXX. So one is 4, another one is 0. So 4 and 0, it can be A and C or C and A. Doesn't matter. So if you let this to be your A is 4, that means your C is 0. If you let this to be your C is 4, that means A is 0. Okay. Then compute for the B squared minus 4AC. Okay, positive, it is hyperbolic. Okay, the last one, what is your B? 2, okay, the one from the mix, B is 2. Okay, the other 2, this one, both are 1. So A is 1, C is also 1. Okay, so when you compute for the B squared minus 4AC, you get 0. That's means parabolic. Okay, put this in your mind. Okay, now we look at this exercise. We try this exercise now. Okay, number one, what is your B? 2. 2. Okay, 2. And your A is 4. That means your C is 0. Okay, so B squared minus 4AC. That means 4. Okay, so when it is greater than 0, what is it? 5. Okay, number 2, what is your B? 0. No, next. So these two, x, y, 2, 2, that means A is 2, C is also 2. So B squared minus 4AC. Negative 16. Okay. Negative means elliptic. Elliptic. Okay, number 3. Number 3, your B is 4. Okay, the next one, 4. So A and C, 1 and also 4. Either 1, 4 or 4, 1, doesn't matter. B squared minus 4AC means 0. So this is parabolic. And the last one, your B is 3. Your B is 3. The one from mix, B is 3. So your A is, okay, if your A is 0, what is your C? Negative 1. Okay, this one. Okay, you have only one key UTT. You do not have UXX. You do not have UXX. So 1, 0, another one is negative 1. Okay, or negative 1, 0 here. Okay, 9 minus 4 AC. That means 9. Okay, greater than 0. Okay, greater than 0 means hyper. The last one is hyperbolic. Okay, any questions? The screen. You can look. You can refer to your handphone. Okay, now we look at the solution of a PDE. Okay. So now this one, UXT is the solution of this PDE. But how are we going to show that this is a solution of this PDE? So it is same exactly as how we show using in the ODE. Okay, we differentiate. So this one, U, from this PDE, we have UTT. Yeah? We have UTT. So from the U, we will differentiate with respect to T twice. We get a UTT from the given solution. Okay. Then this is your U. U is X sine T. So to get the UTT, we have to find for UT first. Okay, UT means we differentiate this with respect to T. Okay, but now you have X and T. So when you are differentiating with respect to T, we assume X to be constant. Okay, we assume X as constant. So when you differentiate sine X, sine T, you get cos T. X is a constant. So you have X cos T. Okay, but what we want is UTT. So you differentiate this one more time with respect to T, X is a constant, so when you differentiate cos t, you get negative sine t times x. Okay, once you get your utt, okay, we will start from the left-hand side. Okay, we start from the left-hand side, this one. Okay, you substitute your utt that you found. Okay, this is your utt plus u. Okay, plus your u is here. Okay, then you simplify and you check whether you get this right-hand side. If yes, that means this is the solution of this PDE. Okay, this is how we show. Okay, now if you look at the second example, this is the given PDE. Okay, you can move this uxx to the left so that we have this. Okay, so later on we find for the utt and uxx from the u, and we substitute into here, and we must get 0. We must get 0 later on. Okay, so now we get the utt and uxx first. Okay, so ut, this is your u. We want to differentiate this with respect to t. So sine x is a constant. Differentiate sine t with respect to t, we get cos t. So you have sine x cos t here. Your ut, yeah? Then we differentiate this one with respect to t one more time to get utt. So cos t, when you differentiate, you get negative sine t. Okay, sine x is a constant. You get negative sine t. Okay. And next, we want to find for uxx. Okay, so ux means that we are differentiating this function with respect to x. Okay, x now, so that means sine t is a constant. Okay, we treat sine t as a constant. So sine x with respect to x, you get cos x. So cos x sine t. Then differentiate this one with respect to x one more time. So cos x, we get negative sine x. Assume sine t as constant. Okay, then this one, we just copy the left-hand side function. Okay, left-hand side function, you substitute utt, and then minus the uxx that you found. Okay, and then you simplify, you get 0. Okay, when you get 0, that means we have done showing that this is the solution of this PDE. Okay. Any questions? Okay, no, then we try this. This is the PDE. Okay, this is the PDE. So we move all the u terms to the left. Okay, so later on we will start from the left hand side. So now we know that we have to find for the ut and uxx. So that's means from here you have to find for the ut, ux, and uxx. Okay, ut means that sine x is a constant. Sine x is a constant. You differentiate this. So what do you get? Minus 4, e negative 4t, sine x. Sine x is a constant now. Okay, then ux differentiate with respect to x. X is here. So that means this is a constant.
cos.
No, this one constant differentiate sine x cos x. Okay, then x differentiate ux with respect to x. Okay, this one. That means this is a constant. When you differentiate cos x, you get a negative sine x. Then we will start from the left hand side. Ut minus 4 uxx. So we just substitute the ut and xx. If we find, then you should get 0. Because you are asked to show that u is the solution of the PDE. Okay, so when you obtain the solution of the PDE, if you solve using analytical method, and you get the solution, final answer, uxt, you can use this way to check whether your answer is correct. Okay, so your ut, just substitute ut is negative 4, e negative 4t, sine x. Then minus 4. Substitute your uxx. Okay, when you simplify 1 plus 1 minus, you get 0. Number 2, ut. T is here. So cos x is a constant. Cos x is a constant. When you differentiate cos t, minus sine t. Okay, utt, one more time, respect to t. Okay, this is a constant now. You differentiate sine t, you get cos t. Okay, differentiate with respect to x. Okay, with respect to x, that means this is a constant. Okay, when you differentiate this one, you get negative sine x followed by cos t. Okay, then once again differentiate this one with respect to x. Okay, sine x. It cos x cos t. Okay, so utt. Okay, we start from the left hand side. UTT minus UXX. We have shown that it is equals to 0. So we need the UXX and UTT. UX, UXX, UT, UTT. Okay, this one, move the U terms to the left. Okay, later on, we should get a 2 on the right. Okay, last one, UX. UX, differentiate with respect to X. So what do we get? 2X plus cos X sine T. Okay, UXX, 2 minus, this one you get a minus sine X sine T. Okay, UT, X squared. Do you still have X squared? Differentiate with respect to T. What is this? When you are differentiating with respect to T, X is a constant. That means X squared is a constant. When you differentiate a constant, you get 0. Okay, here sine T, you get a cos T. Okay, because we are treating X as constant when we are differentiating the U with respect to T. This is a constant. Okay, UTT, differentiate this with respect to T. So we have a negative sign. Okay, this one will be sine T. Okay. So now UXX minus UTT, UXX minus UTT. Okay, 2. Okay. Any questions? Okay, your midterm. Want to return your midterm? Okay, Abdulaziz. Abraham. You take for him. Agane. Everyone. Why not?
Can I take?
Vice Council. Yusha Ishamuddin.
Yes.
This one. See you next week. Next week. Week 12. Are you?
Big by the way, Thomas.